In this video, we're going to talk about kinematics in one dimension or just in a straight line. And we're going to solve some problems associated with displacement, time, velocity, and acceleration. So first, let's talk about displacement. So what exactly is displacement? Basically, when we talk about displacement, it is the distance covered by a certain moving object. So whenever an object is moving and it moves from one position to another position, and the distance it covered is actually the example of a distance. Now let's talk about velocity. What exactly is velocity? When we talk about velocity, as we all know, this is an example of a vector quantity. So it has both magnitude and direction. So whenever there is a moving object and it has a speed, at the same time it has a direction, then that is an example of velocity. Now how about acceleration? What is acceleration? Acceleration is the change in velocity. So whenever a velocity changes over time, acceleration will be produced. And keep in mind that whenever velocity is constant, the acceleration will be zero. And whenever your velocity changes at a constant speed, the acceleration will be constant. Now, there are some equations and formulas you should be aware of whenever you want to identify the value of your displacement, velocity, acceleration, and time. So, when an object is moving at a constant speed, the formula should be displacement is equal to velocity multiplied by time. Now, but when an object is moving at a constant acceleration, your formulas should be final velocity is actually equal to initial velocity multiplied by acceleration and time. Now your final velocity is actually equal to final velocity squared is equal to initial velocity squared plus 2 multiplied by your acceleration and displacement. Now we also have your displacement is actually equal to initial velocity multiplied by time plus 1/2 multiplied by 2 and acceleration and multiplied by time squared. Now we also have your displacement is actually equal to 1/2 multiplied by final velocity plus initial velocity multiplied by again by time. Now these are some formulas or equations you have to keep in mind whenever you want to get the value of your displacement, velocity, acceleration, and time. Now let's try to apply these formulas in some problems. Now for this example, an object is traveling at a constant speed of 25 meters per second. How many meters it will cover after traveling in 1 hour? Now first thing to do whenever we want to solve a certain problem which relates on kinematics, we have to identify the given variables. Now, we know that the object is traveling at a constant speed of 25 meters per second. So therefore, the velocity is actually equal to 25 meters per second. Now we know that the object is traveling for 1 hour. Then we should know that the time is actually equal to 1 hour. So how many meters it will cover? Therefore, we should know that what we are trying to look for is your distance. So what formula should we use? Now from the formulas right here, which of this formula are we going to use? So whenever we have to choose a certain formula, you should have to keep in mind that you are going to find the velocity, time, and displacement. So which of this formula have your velocity, have your time, and your displacement? So we should know that this formula are we going to use. So again, displacement is actually equal to velocity multiplied by time. Now, before we rewrite the given values, we should know that what we are trying to look for is the distance. But with our given values here, we know that we have r and seconds. So we first need to convert these two units to match. Now let's try to convert this one. Now in 1 r over 1, of course, to be multiplied by your conversion factor. Now we know that in 1 hour, we have 60 minutes. Now we also know that in 1 minute, we actually have 60 seconds. Now we have to cancel same units, your hour of course and your minutes. Now seconds are what we are trying to look for, so just bring down seconds. Now 1000 multiplied by 60 multiplied by 60, then you should have the value of 3600. So therefore, 1 hour is actually equal to 3600 seconds. Now we can now rewrite the given values. Now we know that displacement is what we are trying to look for, and your velocity is actually equal to 25 multiplied by your time, and we know that our time is 3600. Now your displacement is actually equal to 25 multiplied by 3,600, then you should have the value of 90,000 meters. So this should be our final answer. So it only says that the object with a velocity of 25 meters per second can travel 90,000 meters in 1 hour, or in just 3,600 seconds. So that is how we do it. Now let's try to have another example. Now for this example, the bus is moving at a constant speed of 13 kilometers per hour. How many hours it will take the bus to travel 2,501 kilometers? Now we know that we have to first identify the given variables. Now we know that the bus is again moving at a constant speed of 13 kilometers per hour. Now we should know that the velocity is actually equal to 13 kilometers per hour. And then the bus traveled for 2,501 kilometers. So therefore, our displacement or distance is actually equal to 2,501 kilometer. Now, how many hours it will take the bus to travel 2,500 kilometers? So therefore, what we're trying to look for is the time. Now again, which of these formulas right here are we going to use? That have your velocity, that have your distance, and that have your time. Then we should know that again, we are going to use this formula right here. Again, whenever we have a constant speed, this will be our formula right here. Again, displacement is actually equal to velocity multiplied by time. Now let's rewrite the given values. Now distance is, or displacement is actually equal to 2,501 is equal to velocity, which is 13, and your time. Now we should know that from our basic algebra, we have to isolate this time because this is what we are trying to look for by dividing both sides by 13. So bring down 13 here, another 13 here. Now cancel this one. Now 2,501 divided by 13, then we should have the value of 192.39 R is equal to your time. So this should be our final answer. Now for this example, it only says that the bus with a velocity of 13 kilometers per hour can travel 2,501 kilometers within 192.39 R. So that is how we do it. Now let's try to have another example. Now for this example, John is riding a car that accelerates from 3 kilometers per second to 123 kilometers in 183 seconds. What is the average acceleration of the car? Now again, identify the given variables. Now we know that John is riding a car that accelerates from 3 kilometers per second. Now we should know that our velocity is not constant. So therefore, our initial velocity is actually equal to 3 kilometers per second. And it goes 123 kilometers per second. Now we should know that final velocity is actually equal to 123 kilometers per second. And it traveled 183 seconds. So therefore, the time is actually 183 seconds. Now, what is the average acceleration of the car? So therefore, what we are trying to look for is the acceleration. Now, looking at these formulas right here, which of these formulas are we going to use? That again have your initial velocity, have your final velocity, have your time and acceleration. Then we should know that this formula right here is what we are going to use because it has velocity, it has initial velocity, it has acceleration at the same time. So let's rewrite the formula. Now again, final velocity is equal to initial velocity plus acceleration multiplied by time. Now let's rewrite the given values. Now final velocity is 123 and the initial velocity is 3 plus your acceleration and your time is 183. Now we should know that we're going to transpose this 3 right here. So 123 minus 3 is equal to 183a. Now, of course, we are going to subtract this one. 120 is equal to 183a. Now, again, we have to isolate this a because this is what we're trying to look for. Now, 120 is equal to 183 acceleration or multiplied by acceleration. Now, multiplied both sides by 183. Then cancel this one. So 120 divided by 183, then you should have the value of 0.66 is equal to acceleration. So therefore, for this example, our final answer is 0.66 kilometers per second squared. So it only says that a John that is riding a car with an initial velocity of 3 kilometers per second and with a final velocity of 123 kilometers per second can travel up to 0.66 kilometers per second squared in 183 seconds. And that's how we do it. Now let's try to have another example. Now for this example, a race car is traveling from rest to 285 kilometers per hour in 1.5 hour. Now what is the average acceleration of the race car? And what is the total displacement of the race car traveled? Now again, identify the given variables. We should know that the race car is traveling from rest. So therefore, our initial velocity is actually equal to 0. And it goes to 285 km per hour. So therefore, our final velocity is 285 km per hour in 1.5 hour. So therefore, the time is 1.5 hour. Now, what is the average acceleration of the car? Now, first thing we have to look for is your acceleration. And also, what is the total displacement of the race car traveled? And we're also going to find the displacement. Now, again, which of these formulas right here are we going to use that have your initial velocity, final velocity, time, and acceleration? We should know that we're also going to use again this formula right here. So let's rewrite the formula. Again, final velocity is equal to initial velocity plus acceleration multiplied by time. Now our final velocity is 285. Our initial velocity is 0 plus acceleration and the time, which is 1.5. Now cancel this one, so 285 is equal to 1.5a. Now again, we have to isolate your acceleration because this is what we're trying to look for. Now 285 is equal to 1.5 multiplied by acceleration divided by both sides by 1.5 and another 1.5 right here. Then cancel this one. So 285 divided by 1.5, then you should have the value of 190 is equal to acceleration. So for this example, the value of our acceleration is actually equal to 190 km per hour squared. Now, let's try to find out our distance or displacement. Now, which of these formulas right here are we going to use? Is it this one, this one, this one, this one, or this one? That have your initial velocity, have your final velocity, have your time, acceleration, and distance. Now, actually, we could use all of these formulas. But let's try first our first formula, which is this one. So again, displacement is equal to velocity multiplied by time. Now, distance is what we're trying to look for. Now, velocity. For our velocity, how are we going to use this final velocity? Now, for us to get our average velocity, we should use the formula of average velocity is actually equal to final velocity minus initial velocity divided by 2. Now, we know that our final velocity is 285 and our initial velocity is 0 and divided by 2. So we should know that 285 divided by 2 and we should have the value of 142.5. So this will be our average velocity. Now let's rewrite the given values. Now for our average velocity right here, we should know that it is 142.5. And the time, of course, we have 1.5 r. So our displacement is actually equal to 142.5 divided by 1.5, and we should have the value of 213.75. So therefore, this will be our final answer. Now let's try to use this formula to check whether we'll be having the same answer. Now again, we should know that our displacement is actually equal to 213.75 kilometers. Now again, let's try to use this formula right here. Now let's rewrite the formula. Again, displacement is equal to 1/2 multiplied by final velocity plus initial velocity multiplied by time. Now displacement, then 1/2 our final velocity, which is 285, cancel our initial velocity because it is just 0, and multiply by 1.5. Now 285 multiplied by 1.5 multiplied by 0.5 or 1/2, then you should have the same value, which is 213.75. So this should be our final answer. So So whatever formula you are going to choose right here, you should come up with the same answer, which is 213.75. Now let's try to have another example. Now for this example, a bicycle travels from 14 meters per second to 28 meters per second and covered a total distance of 7,500 meters within that period. Now, how long did it take the bicycle to travel 750 meters? What is the bicycle's acceleration? Again, let's try to find the given variables. Now we should know that the bicycle travels from 14 meters per second. So therefore, our initial velocity is 14 meters per second. And it goes to 28 meters per second. So therefore, our final velocity is 28 meters per second. And it covered a total distance of 7,500 meters. So therefore, our displacement is 7,500 meters. Now, how long did it take the bicycle to travel 750 meters? So therefore, time is what we're trying to look for. Now let's try to solve first your time. Now again, which of these formulas are we going to use again? That have your initial velocity, final velocity, distance, and time. We should know that we are going to use this formula right here. Now let's rewrite the formula. So again, displacement is equal to 1/2 multiplied by final velocity plus initial velocity multiplied by time. Now our distance is 7,500 is equal to 1/2 multiplied by your final velocity, which is 28, plus initial velocity, which is 14, multiplied by time. Now 7,500 is equal to 1/2 multiplied by 28 plus 14, then we should have the value of 42 multiplied by time. Now 7,500 is equal to 1/2 multiplied by 42, then we should have the value of 21 multiplied by time. Now we have to again isolate this time by dividing both sides by 21. 21 here and 21 here. Now cancel this one. Now 7,500 divided by 21, then we should have the value of 357.14 is equal to time. So therefore, the time that we are trying to look for is actually equal to 357.14 seconds. Now, what is the bicycle's acceleration? Now again, what we're trying to look for is your acceleration. Now let's have some space first. So again, acceleration is what we're trying to look for. Now which of these formulas right here are we going to use? Now we actually use all of these formulas right here, but let's just use this one. So let's rewrite the formula. So final velocity is equal to initial velocity plus acceleration then multiplied by time. Now our final velocity is 28, then our initial velocity is 14 plus acceleration is what we're trying to look for, and your time is 357.14. Now transpose your 14 right here. Now 28 minus 14 equal to 357.14 multiplied by acceleration. Now 28 minus 14, then you should have the value of 14, of course. Then 357.14 multiplied by acceleration. Now again, we have to isolate your acceleration right here. So 357.14 and again 357.14. Now let's cancel this one. Now 14 divided by 357.14, then you should have the value of 0.04 is equal to acceleration. So therefore, our answer right here is actually equals to 0.04 meters per second squared. So therefore, the bicycle with an initial velocity of 14 meters per second and with a final velocity of 28 meters per second can travel 7,500 meters in 357.14 seconds and with an acceleration of 0.04 meters per second squared. So that is how we identify your displacement, velocity, acceleration, and time using your kinematics. So thank you for watching.